So hey, before we start with the actual maths today, I have got a maths rhyme that I would like for you to learn. Put it in here, learn it, put it in here, because when you have to calculate with fractions, this little ditty is going to help, I promise. It goes a little something like this. Multiplying fractions is no big problem. It's top times top and bottom times bottom. Dividing fractions is easy as pie. Just flip the second fraction, then multiply. If adding or subtracting is your aim, then the denominators must be the same. Change the bottom, see, I haven't learned it yet, but you'll get there. You'll get there before I will. Change the bottom number with a times or divide, but the same to the top number must be applied. And don't forget to simplify before you say goodbye. That means goodbye to that problem. Before you leave that problem, make sure it is in its simplest form. Today, though, we're only really going to focus on the first and last part, because always with fractions, unless you're asked otherwise, you should put the fraction in its simplest form. But the maths that we're going to look at today is just multiplying fractions, because multiplying fractions is no big problem. All we're going to do is top times top and bottom times bottom. You can do it. Let's get to it. Okay, so before we have a close look at the kinds of fractions that you are likely to encounter in your school career, we are going to dial it back a bit. You know how I say in class, if you're ever not sure about doing a particular calculation or a particular word problem, to try substituting some of the numbers for easy numbers, from small numbers or numbers that you can work really easily with. It won't give you an answer, and of course you always have to keep the relative values the same, but sometimes just working with those manageable numbers helps you understand the process that much better, and then you can apply that understanding to some more complicated maths. And we're going to do the same thing. So thinking about our multiplying fractions, no big problem, top times top and bottom times bottom, we're going to take the easiest fraction that I can think of, which is 1/2. Let's multiply 1/2 by 1/2. Just have a think and see if you can work out what's going to happen. Now, I'm going to tell you this. If you know the process, top times top and bottom times bottom, you're pretty much set. But to really understand what's happening, we're going to have a look at it. And what I have found kind of messes with people's heads is the fact that when you multiply fractions, you get a smaller amount. And all of the time you have been multiplying, you kind of get this idea that your value, your product, right, is going to be bigger. I always put a little caveat. I always say, well, you know, if you multiply by 0, you're going to get 0. If you multiply by 1, you're going to get the same amount. But generally, you expect that when you multiply numbers, you get bigger amounts. However, if you multiply with less than numbers, you're going to get, I say less than numbers, you know, numbers that are less than 1, you're going to get smaller results. And that messes with people. So let's really look carefully at what happens when you multiply fractions. And we'll start with 1/2 times 1/2. Okay. So you can see here, I've already done that for you. 1/2 times 1/2 is 1/4. Well, why? Well, let's come down here. We've got our top times top and bottom times bottom. So we're multiplying each numerator and we're multiplying each denominator. And so we've got 1 times 1 is 1, 2 times 2 is 4. So 1/2 times 1/2 is 1/4. But why? Well, let's think of it like this. Something else we talk about in class is sometimes if you kind of take yourself back a bit and don't get so completely wrapped up in the concept and the numbers, and think about how it works in the real world. So here we are. We've got a pizza, right? We've got a nice big, lovely pizza. dripping with cheese. Yum. And what we're only going to do though is we're only going to look at a half. Okay? One half is gone to the side or eaten by the dog, whatever. We've only got a half a pizza. Okay? So there's our first one half. But I say I only want one half of a lot of that half of a pizza. Okay? So here I start with my half of a pizza, you see? All right? Now I'm going to have half of that lot. Half of one half. And what do we get? If I start with my half, well, there's my, I'm imagining the whole pizza, and then I'm looking at a half, and then I'm doing a half a lot of that. What have I got? 1/4. Because I'm having half of a lot of half of pizza. That's my bit of pizza. That's one bit out of then 4 equal parts in the whole. A half of a half, half times a half equals 1/4. And that is why this works. 1 times 1 is 1, 2 times 2 is 4, top times top, bottom times bottom, 1/4. If you need to stop and watch that again or try it out on a piece of paper yourself, do it, play with it, and then come back because we're going to move it on to the next stage when you're ready. Okay, baby steps here. So we're going to start with 1/2 again, but let's make the next number that we multiply it by a little bit more interesting, but not too intimidating. So I think what we'll do is we'll do 1/2 times 3/4. So I'm going to do the same thing again, just the process, top times top and bottom times bottom. And I get this, okay? 1/2 times 3/4, that's 1 times 3 is 3, 2 times 4 is 8. 1/2 times 3/4 is 3/8. You can stick it on the paper and think I'm done, but it's much better if you understand why. So we're going to break it down yet again. So again, here's my pizza. I'm going to start with my half a pizza again. It is worth remembering though, before I tell you this, that multiplication is communicative, and that means we can multiply the numbers in any order and get the same result. This is something that you learned way back in Key Stage 1. 3 times 2 is 6 is the same as 2 times 3 is 6. It doesn't matter which order you multiply them, you're going to get the same product. So whatever you're doing, make it easier. If it's easier for you to think about it as 3/4 times 1/2, you can do that. 1/2 times 3/4, it doesn't matter. I'm going to start with my 1/2 of a pizza again. Okay? But this time, I want more than a half of that half of pizza. I want 3/4 of that half of a pizza. Let's see how that's going to work. Here's my half of pizza. Okay? But I need to quarter that. And I need to also remember that even though I'm only looking at half of that pizza, I need to remember that that half of a pizza was once part of a whole. Okay? I'm only going to be looking at part of it, but just in the back of my mind, I know that it was part of a whole pizza. So, here we go. If I'm looking at quartering a pizza, I'm going to be looking at halving and halving again. So here, I've quartered it. I don't have 3/4. Okay, so I need to quarter it again. In fact, 3/4 means that I need to quarter the kind of whole pizza 3 times. Okay, and if I do that, then I'm looking at 8 pieces in the whole pizza. I'm looking at eighths. Or I'm not looking at eighths, I'm thinking about eighths. But I can leave that half of the pizza to the side for 1 minute. Okay, back to my half of the pizza. Yeah, lefts and rights don't work with me on this video. So here I had my half. I then split my half into quarters. Into quarters, I-N-T-O, into quarters, okay? So now you can see that I've got quarters in my half of the pizza, and if you look really carefully, I'll put it a bit closer, you can see I've kind of tried to color code it. So one half of the pizza is in gray. That's the half that we're not looking at. The other is outlined in black, but you can see that I've got colors now where I have quartered that half of the pizza. Okay, so I've now got 4 quarters within half of a pizza. And what I want to do is I want to separate out 3 of those quarters because I'm having 3 quarters of half of the pizza. Okay? And if you look here, boop, 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 I've colored it in pink, 3 quarters of 1/2. Okay? So that's 1/2 times 3 quarters, or 3 quarters times 1/2, however you want to think about it. And then if I go back to remembering that 3 quarters of half of a pizza actually belongs to a whole amount. In the whole amount, if I divided it up, as I did, I had 8. I had 3 pieces out of 8 pieces in the whole pizza. That's 3/8 of the whole pizza, but only 3 quarters of half of the pizza. That is why that works. And if you need to think about it a little bit, go ahead. But if you just remember top times top, bottom times bottom, that will give you the answer that you need. Now you have the understanding underneath it all to make sense of it. I hope. Watch it again, play with it again, fast forward if I'm confusing you, but I'm trying to make sure you understand the concept as well as the process. Fingers crossed. We're going to move on to non-unit fraction multiplication next, when you're ready. Okay, I think we're ready now to move on to the kinds of questions that will be more typical when you're in year 6 and just going into year 7. That will be multiplying with non-unit fractions. If you remember, unit fractions are fractions where the numerator, the number on top, is 1. You are more likely to multiply with fractions that have numerators other than 1. So multiplying with non-unit fractions, we're going to stick with 3 quarters because we used it the last time, but we're going to multiply it by a non-unit fraction, and in this case it's going to be 2/3. So we've got 3 quarters times 2/3. If we remember, multiplying fractions, no big problem, top times top and bottom times bottom. So we've got 3 times 2 is 6, that's the numerator, top times top. 3 times 4, bottom times bottom, that's 12. That gives us 6/12. Now, you're all smart enough to look at that and know that 6/12 is not the finished article. Remember to simplify before you say goodbye. And we can just look at that. We don't need to worry about finding highest common factors or anything else. We can just look at that and say, I know that 6/12 is equivalent to 1/2, which is the simplest form I can make that fraction. I'll try to make this one a little speedier in terms of understanding why that's the case. Why on earth would 3 quarters times 2/3 equal 1/2? It kind of seems counterintuitive. So instead of using pizzas this time, I'm going to use a Swiss roll. Okay, I've got a nice big long lovely yummy Swiss roll that has been chopped up into quarters, and one of those quarters has already kind of been claimed. Here we are. So I'm looking at, and of course remember our problem is 3 quarters times 2/3. Why is it 1/2? So here's my Swiss roll divided into quarters. There are my 3 quarters that I'm looking at right there, and one of those quarters has been claimed. Now, in order to do 2/3 of the lot of that 3 quarters, I of course need to cut all of the quarters into thirds. And even if that Swiss roll has been eaten by some cheeky little thing, I need to sort of even mentally divide the missing piece of the whole the same way I've divided the pieces that are there, just to keep it fair and even. Okay, so here we are in the second picture. I'm trying to make that straight. I've got my quarters, which I have now chopped each of those into thirds. Actually, that one I'd sort of stupidly divided into quarters, but you didn't see that, did you? No. Can you see that? Now, each of my 3/4 has been divided into thirds. You got that? And I want 2/3 of those because it was 3/4 times 2/3. So you can see here are my 3/4, and I'm having 2 of those. So here are the 2/4 of the Swiss roll that are all for me. Well, how many bits of that Swiss roll? 3, that's 6. 6 out of how many in the whole? That includes the missing bit. So it's not out of 9, it's out of 12. 6 bits of 12 is a half. So I've had, by having 2/3 of the 3/4 that were left, I've had half of that whole Swiss roll. Just put it up there again so you can kind of digest it. There it is as a picture. And here it is as the simple method, top times top, bottom times bottom. Next, we're going to multiply a fraction by an integer. And you will see lots of this in your work. It's a lot easier than it first appears. We're going to apply the strategy and then look for a shortcut. Shortcut where you cheat using your own brain. Okay? When you're ready, take a breath and join me back here when you're good to go. Okay, so the question is, and the question that I've had is, well, what do you do if you've got a whole number and you've got to multiply that by a fraction? How on earth can you do top times top and bottom times bottom? It's actually quite easy. We're going to find out about it and then actually kind of put it to one side and think about an easier way. But just so you know, it does work, and it can work, and you might need it for when the shortcut doesn't work. We're going to look at that first. So top times top, bottom times bottom. Excuse me. What if I had something like 5/12 times 180? Bing, the light bulb goes on. We know, don't we, that any number multiplied by 1 is always itself, right? So 580 times 1 is 580, right? Right. Let's use the inverse in order to make a fraction. So I could say always that 580 is the same thing as 580 over 1, because I can always divide it by 1 and come up with the same number. Okay? You know when we were doing decimals, I always say, well, any number could have a decimal, any integer. You could put a decimal point and put 0, infinite number of zeros. Any number that's an integer could become could have a decimal point at the end. The same thing applies in some respects with integers and fractions. You can make any integer into an improper fraction by making its denominator 1, because you flip it and divide it by 1, you're going to get the same number. So, for instance, can you see that? 1 is the same as 1 over 1. 2 is the same as 2 over 1. 3 is the same as 3 over 1. 54 is, anybody want to have a guess? You could use the inverse. 54 times 1 is, yes, it is, in fact, 54 over 1. You could have 7,901 and express that as an improper fraction. Yes, you got it, 7,901 over 1. Could you do, I'm just thinking about the kinds of questions I get in class. Could you do infinity over 1? Perhaps theoretically, I'm not clever enough to work that out, but it's just silly. So we'll leave that to one side. Any number though, if you have any integer that you have to multiply by a fraction, you can always make into a fraction by giving it the denominator 1. In this case then, we're going to put 180 over 1. So now I can in fact do top times top and bottom times bottom by saying 5/12 times 180 over 1. Okay, so then I have 5 times 180 over 1. There is a way where you can make some of these numbers smaller and easier, but we're going to leave that for another video because that could confuse people. So now I have got 5 times 180 over 12. So we need to work out what 5 times 180 is. Hopefully you use your superhero 0, cloak of invisibility, cover up that 0, and now you're really only calculating 18 times 5. You probably could do this mentally, but just to keep track of things, let's do a little bit of quick column multiplication, and we have 90. 18 times 5 is 90, but of course we used our superhero 0, get that 0, whack it back in its place, and we'll have 180 times 5 as 900. Can you see that? Yeah. Okay, so now we've got 900 over 12. That's one whopping, crazy improper fraction. Can you remember how to sort out improper fractions? Hopefully you can, and you know that you just divide. Because that is what a fraction is anyway, isn't it? It's a division. So we have 900 divided by 12. There are a couple things we could do. We could just do it as is. Okay, we could say 12 into 900. Well, 12 goes into 90. It goes 7 times because I know my 12 times tables, because you should know your 12 times tables. I know that 12 times 7 is 84. Okay, and then that gives me a remainder of 6, which I put in here. So now I've got 12 into 60, and that goes 5 times. We know that. So 900 divided by 12 is 75. If you wanted to be a little bit clever and make things a bit quicker, you could of course simplify. You could say to yourself, well, just looking at that number, I know that both of those numbers are even, so I could make this much quicker just by dividing each by 2. And instead of 900 over 12, I've now got 450 over 6. 6 seems a little bit of an easier number to divide by. So I've got 6 into 450. 6 goes into 45 7 times because 6 times 7 is 42. Okay, that gives me a remainder of 3, which I put in front of my 0 there, which means that 6 into 30 goes 5 times. I've got 75 again. So to recap, we started with 5 twelfths times 180 is the same as 5 twelfths times 180 over 1. Multiplying top times top, bottom times bottom, I've got 900 over 12, which means I have to divide. 900 divided by 12 is 75. Therefore, did I do a little therefore sign? Can't see. Therefore, 5 twelfths times 180 is 75. So to recap, you can, in fact, do top times top, bottom times bottom as a strategy when you're multiplying by an integer, simply by sticking a 1 underneath as a denominator. That's the strategy. There's an easier way, but you need to know that first. If you need to try it, if you need to look at this again, if you need to have a cup of hot chocolate or something and come back, our very last section of this video is going to look at multiplying by integers and making it that bit easier. The light is at the end of the tunnel. We're nearly there. It is worth bearing in mind that I'm looking at a whole concept, which normally we would look at over the course of the week. This is just one big long whistle-stop tour of multiplying with fractions. So we're looking still at multiplying an integer by a fraction, and now we're looking at the shortcut. In order to understand the shortcut, let's apply the strategy we've just used, which is to make any whole number into a fraction by giving it the denominator 1. Whole number, now improper fraction with 1 underneath. So taking our last multiplication, we had 5/12 times 180. I'm going to scale it back so as to make it a lot more manageable. I'm going to turn the 5/12 into 1/2. It's fairly 5/12 is fairly close to 1/2. Half is really nice and easy. 180, I'm just going to divide by 10. I've got 18. So now my calculation to help us understand this new strategy is 1/2 times 18. Hopefully you have put in your head or put on a paper 1/2 times 18 over 1. Top times top, bottom times bottom, looking a little something like this. That star is because there is a way to make that process a lot easier. We're going to leave that for 1 minute. Okay, and then of course you get the improper fraction 18 over 2, or 18 halves. Can't leave it like that, so you need to divide it, right? You could do your bus stop, you could do your bracket division. You don't need to though. You can look at 18 halves, you can look at 18 over 2 and know that 18 divided by 2 is 9. That means, therefore, that 1/2 times 18 equals 9. Light bulb going on for lots of you, I hope, saying, well, hold on, that's just the same as saying half of 18 is 9. I know that. I know you know that, and that's going to be our strategy, because all you're doing here is what you've done for many years and thinking about it and recording it in a much more mathematical way. You've always, not always, but for several years been able to do half of a number, a quarter of a number, 3/4 of a number, or of an amount, shall I say. And we're saying 1/2 of. The mathematical way to do it, I do it in class all the time and lots of you notice it. Instead of writing OF, we write this. And that's what we're going to be doing to help us work it out. Okay, so once you understand that multiplying a whole number by a fraction is the same as saying the fraction of the number, you're good to go. Let's apply that with some non-unit fractions, and let's look at both strategies side by side. So instead of having 1/2 times 18, let's give it a non-unit fraction. Let's say it's 2/3 times 18. And if you were doing the standard method, top times top, bottom times bottom, you would have 2 over 3 times 18 over 1. My 1 looks a little bit like a 2 there, but it is a 1. So 2 times 18 is 36. 3 times 1 is 3. And then hopefully you have found your answer there, either by simplifying or using brackets and finding out that it's 12. Okay? But, of course, you can think to yourself, well, this question is asking me, really, what is 2/3 of 18? Most of you will remember this from your work in years 4 and year 5. So, to find 2/3 of 18, you first need to find 1/3 of 18. Okay? 2/3 times 18 is the same as 2/3 of 18. So first I need to find out what is 1/3 of 18. And I'll ask myself, what are the factors of 18? In other words, what goes with 3 to make 18? In other words, 3 times what is 18? Of course, you know, it's 6. So that doesn't give me the answer. That just tells me how much 1/3 of 18 is. 1/3 of 18 is 6. Therefore, if I've got 2/3, that must be 12. So 2/3 times 18 is 12. I can do it the long way by giving it the 1 as the denominator, or I can just say what is 2/3 of this amount. Does that make sense? I hope it did make sense, and to be sure, we're going to compare the old method with the new method by going back to our first question in this section, where we had 5/12 times 180. Just to remind you, this is what we did. We said 5/12 times 180 over 1, top times top, bottom times bottom, top times top, 5 times 180 is 900, bottom times bottom, 12 times 1 is 12. That means we had 900 over 12. We had to then divide, of course. 900 divided by 12 gave us 75. That was method 1 condensed. So now I hope you're ready for method 2, which is the method that lots of people find easier, just thinking to themselves that in these calculations, this just means of. So 5/12 times 180 is the same as saying what is 5/12 of 180, right? So I need to know actually first, what is 1/12? 5/12 of 180 sounds a little bit tricky. 1/12, doable. Different ways you could do it. You could use 12 times table, get up to 144, work up from there. Quick and easy would just be to use your bracket division and say to yourself, how many times does 12 go in to 180? Well, 12 goes into 18. I use the 0 as a placeholder there. You don't need to. I did it so you can see how the digits are lined up. 12 goes into 18 one time. That gives us 6 left over, a remainder of 6. I've still got a number in my bracket, so I'm going to put the 6 in front of the 0. Therefore, 12 into 60 goes 5 times. We know that. Therefore, 1/12 of 180 is 15. However, it didn't ask us for 1/12. It asked us for 5/12. So we need 15, 15. We need 5 of those. So I need to say, what is 15 times 5? Hopefully, you can work that out fairly easily. We know that 15 times 4 is 60. Put another 15 on. But if you're not sure, you could always do a little bit of column multiplication. 15 times 5 equals 75. Therefore, 5/12 times 180 equals 75. Hope that's working for you, because now you've got a job and you're going to help me look at this question from a past SATs paper. It's a question that I've had and I want to pass it back to you. So the question is, excuse me, 5/6 times 540. I'm going to do the long way really quickly, and then it's over to you to do it in method number 2. So 5/6, top times top, bottom times bottom, that's method 1. 5/6 times 540 over 1. What I'm going to do is I'm going to just use my superhero 0 really quickly and say 54 times 5. You see that? I'm not just going to talk it all through, but you can see what I've done there. Okay? I'm going to use my superhero 0, put superhero 0 back in place, and that gives me a total. 5 times 540 is 2,700. Can you see why method 1 can sometimes take a really long time? Method 2, you will find much more quick and easy. So now I've got 2,700 sixths, and I've got to divide that, which I have done there, you can see. Over to you now, method 2. 5/6 times 540 is the same as saying 5/6 of 540. How will you do it? I hope you will find 1/6 first. What do you know that might help you? I hope some of you will use your superhero zeros. Give it a go, and I'd like for you to be able to prove that 5/6 of 540 is in fact 450? Can you prove that 5/6 of 540 is 450? Over to you. Any questions? Let me know. Well done.